All right, so now we want to talk about what are called mutually exclusive events. Events that cannot occur at the same time are called mutually exclusive events. Suppose you wanted to find the probability of drawing a heart or a diamond. Since a card can't be both heart and a diamond, the events are mutually exclusive. Now, if you wanted to find the probability of picking a heart or a jack, those are not mutually exclusive because you can pick a card that is a heart and a jack at the same time. Okay, so let's look at some examples of mutually exclusive events. Mutually exclusive events in an Venn diagram, the two events would not overlap because they cannot occur simultaneously. They're mutually exclusive. So the probability that you do this or that, you just add the probabilities. And notice the word "or" is going to often come up in these types of problems. So if die is being rolled, find each probability. Probability of picking a 3 or a 5. Can you do that at the same time? No. You either roll a 3 or you roll a 5. So on a dice, a standard dice has 6 sides. 1, 2, 3, 4, 5, 6. Okay, we're not talking about a 12-sided die or some kind of weird one. Since a die can't have both 3 and 5 at the same time, the events are mutually exclusive. So the probability of rolling a 3 is 1 out of 6. A 5, same thing, 1 out of 6. So rolling a 3 or a 5, you just add those together and you get 2/6 or 1/3, which is about a 33% chance of rolling a 3 or a 5. Now, what's the probability of rolling at least a 4? Now, at least a 4 means 4 or more. Okay, if you have to be at least 12 to ride the ride at the amusement park, if you're 12, you can ride it, and anybody above that. So at least 4 means 4 or 5 or 6. These are still mutually exclusive events because you can't roll a 4 and a 5 or a 5 and a 6 or a 4 and a 6 at the same time. Okay, so you need to find the probability of rolling a 4, 5, or a 6. Probability of rolling a 4 is a 1/6, a 5 is a 1/6, and a 6 is a 1/6. And you add those together, you get 3/6 or a half, which is about 50%. And think about it. 4, 5, and 6 is half of the sides of the dice in this situation. Okay? All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So probability of less than a 3. Now, it doesn't say less than or equal to a 3. It says less than 3. All right? So you would have to do the probability of 1 plus probability of 2. Don't try to do probability of 0 because you can't roll a 0. All right, so that's 1/6 plus 1/6, which is 2/6, which is 1/3, or about 33%. Okay, probability of an even. Even are 2, a 4, or a 6. Okay, you can't roll either of those at the same time, so those are all mutually exclusive. So you do the probability of a 2 plus the probability of a 4 plus the probability of a 6. So that's 1/6 plus 1/6 plus 1/6, which is 3/6 or 1/2 or 50%. Okay, so 50% of the time you would roll an even. That's the probability there. All right, suppose you wanted to find the probability of randomly drawing a 2 or a diamond from a standard deck of cards. Since it's possible to draw a card that is both a 2 and a diamond, these events are not mutually exclusive. These are the tricky ones. But if you think about them right, they are not as tricky. So the probability of rolling a 2 or picking a 2 is 4 out of 52. The probability of picking a diamond is 13 out of 52. Now, remember, we're just picking one card, and we want to know what are the chances it's either a 2 or a diamond, okay? But something else can happen. You could pick a card that's a 2, you could pick a card that's a diamond, or you could pick the one card that is a 2 and a diamond. So what do? Well, think about it like this. There are 4 2s in the deck of cards, so you counted all 4 of the 2s here. There are 13 cards in a stack of cards that are diamonds, so you counted all 13 of them there. But there's one card that has a 2 and a diamond, so you actually counted it twice. You counted it in the group of 2s, and you counted it in the group of diamonds. Okay? So you actually, if you were to just add the probability of 2 and the probability of diamonds together and get 17 out of 52, it would be incorrect because you counted this card 2 times. You counted it as a 2 and you also counted it as a diamond. So in the first 2 fractions above, the probability of drawing the 2 of diamonds is counted twice, once in the 2's and once for the diamond. To find the correct probability, you just subtract the overlap part. You subtract the probability of picking the 2 of diamonds from the sum of the first 2 probabilities. So the probability of picking a 2 or a diamond is you add the probability of the 2 to the probability of the diamond, and then subtract the probability of picking it both at the same time. This you only subtract when the events are not mutually exclusive. So you do 4 52ths plus 13 52ths subtracted by 1 52nd. Okay, and that would be 4 out of 13, or about 31% chance. So probability of events that are not mutually exclusive. If 2 events, A and B, are not mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities decreased or subtracted by the probability of both occurring. So the probability of A plus the probability of B minus the probability of A and B. Now, why didn't we subtract when we did events that are mutually exclusive? Because the probability of 2 events occurring at the same time that are mutually exclusive is 0. Okay? Like you can't roll a 2 and a 6 at the same time. The probability of rolling a dice one time and getting a 2 and a 6 at the same time is 0. It can't happen. Okay? All right, so let's look at an example. Of 240 girls, 146 are on the honor roll, 48 play sports, and 36 are on the honor roll and play sports. What is the probability that a randomly selected student plays sports or is on the honor roll? Since some students play sports and are on the honor roll, the events are not mutually exclusive. The probability of sports is 48 out of 240. Probability of honor roll is 176 out of 240. And the probability of sports and honor roll is 36 out of 240. So you add the first 2 up and subtract the overlap, and you get 188 out of 240, or 47/60ths, or about 78%. Now let me show you something here. Okay. This is how you would draw the Venn diagram. So this would be honor roll, and this would be sports. So the easiest way to do this is to start with the overlap. How many play both, or how many do both? Honor roll and sports, 36. So you put your 36 in there. Now, the circle of sports represents all the girls that play sports. That would be 48 total. Well, if 36 of them are on the honor roll also, then that leaves only 12 that just play sports. Okay? Now, for the honor roll, we know 176 students are on honor roll, but 36 of them are already playing sports. Okay, so this 36 of them is already accounted for. So that means that there are 140 that are on the honor roll, but not on or not playing sports. Okay, now if you add these all up, so 140 plus 36 plus 12, you would get 188, which is not 240, right? Because 240 is the total number of girls. That would leave 52 girls out. And what they would be is you'd put them over here in the corner. And it doesn't represent the page number or anything. What that represents is the number of girls that don't play sports and are not on honor roll, or are not on honor roll and sports at the same time. It's all the other girls in the class. Okay? So the easiest way to draw the Venn diagram is start with the overlap part, and then subtract that from the total of the other 2 sections to get the 140 and the 12. And then if you add those 3 numbers up, and it's not equal to the total, that means that there's some not accounted for. In this case, 52 of the girls didn't play sports and weren't on the honor roll. Okay? All right, so out of 5,200 households surveyed, 2,107 had a dog, 807 had a cat, 303 had both a dog and a cat. What's the probability that a randomly selected household has a dog or a cat? Go ahead and pause the video. Okay, we're back. So probability of a dog or a cat is equal to the probability of a dog plus the probability of a cat. And there were some houses, these are not mutually exclusive because some houses had a dog and a cat. So if you're trying to find the probability of a dog, you might have picked a house that has a dog and a cat. So I accidentally put a plus sign there. So you have to subtract the probability of a dog and cat. So the probability of a dog is 2107 divided by 5,200 plus probability of a cat 807 divided by 5,200 minus probability of a dog and a cat is 303 over 5,200. So it's 2107 plus 807 minus 303. Since they all have a common denominator, I can just add and subtract the numerators and get 2611 over 5,200, which is about 0.502, which as a percent is about half the houses have a dog or a cat. Okay, now let me show you the Venn diagram. So the box represents all the houses. There's 5,200 houses. This would be the dogs. This would be the cats, because some have dogs and some have cats. Where the two circles overlap, that represents the houses that have dogs and cats, and that would be 303. So if I want the houses that just have a cat, I could subtract that from 807, which gives you 504. So 504 of the houses just have cats. How many just have dogs? We'd have to do 2107 minus the ones that have dogs and cats, so minus 303, which gives you 1804. Okay, so if you add those three up, 1804 plus 303 plus 504, you would get 2,611. Okay, which coincidentally, not coincidentally, is this number right here. Okay, well, that's how many households have a dog, just a cat, or have a dog and a cat. Notice that's not the total number of households. If you subtract that, you get 2,589. That would be the number out here, 2,589. And what do you think that number represents? Right, it represents all the households that do not have a dog or do not have a cat or do not have a dog or a cat. Okie dokie? All right. Well, that's it for this video lesson. Please continue on to your assignment. And as always, reach out to me if you have any questions. Take care.